Hey Chem Stars, it's Ms. McCauley bringing you your Chapter 2 review. We're going over pages 23 and 24 in the Chapter 2 practice packet, which will get you ready for the test. So when you're watching this video, make sure you have everything already attempted, and we're just checking our work here. So here's the first one, scientific notation. We're going to convert numbers into and out of scientific notation. So a couple little quick reviews. Our number should be bigger than 1 and less than 10. And we should write it times 10 to some power. Positive exponent equals a big number. Negative exponent equals a really, really small number. And also remember, 10 to the 0 power equals 1. We might need to use that sometimes. Okay, so when I'm looking at number 1, I first want to figure out where my decimal is. It's right here. And I want to figure out where it needs to be. I need the decimal to be right here because that way it's going to give me 8.97. 8's bigger than 1 and less than 10. Okay, that's my new decimal. Now all I have to do is count how many times I need to move it to get to that. So it's going to be 8.97 times 10 to some power. And that power we're going to figure out by counting how many hops we go. How many powers of 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I just moved my decimal 13 places. We're almost done with this problem. Before you finish, look back to the sign. If it's a positive exponent, it's a really big number. Is that a really big number? No. So we've got to say it's 10 to the negative 13th power because it's a really small number. Now if we compare that to number 2, okay, where's my decimal? It's implied, it's hidden right here. Where do I want my decimal to be? I want to get 7.46. So I'm going to have 7.46 times 10 to some power. Now let's count how many times we've got to move here. 3, 6, 9, 10, 11. I've got to move 11 times. Now I've got positive 11 right now. Is this a really big number? Yes, then the exponent's positive. Ooh, number 3 is the tricky one here. 3.43. That seems right. Can't I just say 3.43? Well, they want it in scientific notation. So it's really 3.43 times 1. So we're going to use that times 10 to the 0 identity. Okay, that might come up. Now, this next part, we have to go out of scientific notation. So look at our number, 1.38, positive 3. I've got to make this number bigger. So what way will I move the decimal? I'm going to move it this way, to the right. 1, 2, 3, there's my new decimal. And any empty loop-de-loops, put a placeholder 0. So that's 1380, 1,308, or 1,380. Now how about number 5? 5.0 times 10 to the negative 3. That means it's going to be a small number. So here's the decimal. I've got to move it 3 times to make it a small number. 1, 2, 3. So I've got 0 point. Now how many little empty loops are there? 2, 5, 0. Now why did I keep that 0 in the end? Technically for Sig Figs. Okay, number 6 is a tricky one. You won't have one like this on your test probably, but knowing how to do it is helpful. You can use some exponent tricks, but to keep it simple, we'll just go longhand and figure this out. So if you notice, they have 740 times 10 to the negative 9th. That's not right because this number isn't bigger than 1 and less than 10. So here's what we're going to do. We're going to put it into standard form, then convert back to scientific notation. So if we have 740, decimals right here, let's put it out in standard form. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my new decimal, and I'm going to fill in all my little placeholder zeros here. Okay, so can you see that this is that number in standard form now? Now, let's actually put the decimal in the right place. It should be right here, between the 7 and the 4. So we're going to get 7.40 times 10 to some power. Decimals here, 1, 2, 3, 4, 5, 6, 7. 7.40 times 10 to the negative 7 is a small number. The little trick you could use here, we've got too many place values. Look at 9 and 7. Those are 2 apart. But if you're not sure, you can go ahead and do it longhand. Okay, our next section, accuracy and precision. Jenny measures the density of aluminum as 3.4. Oh, my smart screen is not letting it operate. 3.4, 8.8, and 3.2. The actual value was 2.7 grams per milliliter. So was she accurate? Let's think about what accurate means. It means close to the given value. 3.4, 8.8, and 3.2. Was she accurate? Kind of. 3.4 and 3.2 were okay. 8.8 was bad. Is she precise? Go back to the definition of precise. That means getting the same thing every time. No way. Didn't get same value each time. Okay. So in that same kind of accuracy and precision thought process, which ruler below has the greater precision? It's going to get us the same value every time. It's going to be B. Why? It has smaller or more gradations or marks. Okay? So if we look at A, it's between 7 and 8. So I can read the 7. Now I can guess my 10th place. I bet 7.5 is about there. So I'm going to say, I don't know, 7.4. That only has 2 sig figs. I read one and I guessed the second sig fig. But compare that to ruler B. Okay, here I can see 7.1, 2, 3, 4, 5. So here's 7.4, here's 7.5. I'm somewhere right in the middle. I can read that it's definitely bigger than 7.4, and I'm going to guess that it's 7.45. This time there's 3 sig figs, 2 that I could read, and then the third one that I guessed. So this is a much more accurate and precise reading than the other ruler. Okay, now let's look at the last one on this page. Reading graduated cylinders. Remember, we want to read at eye level. So here's my eye. I want to read right at eye level, and I always want to read the bottom of the meniscus. So before we figure out which one has the greater precision, we have to figure out the scale. So here's 40, here's 50. 1, 2, 3, 4, 5. There's only 5 lines between those 10 difference, so each line must be 2 millimeters. So that means on this cylinder, I can read to 2 milliliters. That means, this is kind of weird, but just go with me here. That means you can guess to the nearest 1 milliliter. I couldn't guess tenths on that one. Now come over to B. Okay, here's 6, here's 7. This has to be 6.5, 6.6, 6.7, 6.8, 6.9, 7. So I can read every 0.1 milliliter. That means that you can guess to the 0.01 milliliters. You can guess another place value. So which one of these is going to give you a greater, more accurate, more precise answer? It's going to be B. So it has a much smaller scale with more measurements or more gradations. Okay, so what's the reading on A? Okay, this one's going to be a little tricky here. So 32, 34, 36, 38. Now, I know that is exactly on that line. Let me erase my marks here so we can be sure of that. It's right on that 38 line. So I've got to do something that says I know it's 38. This right here only has 2 sig figs. I'm going to call it 38 point. I'm saying I am certain about that. This one we could say 38.0. It gets weird when we're guessing the ones place value and not going to the tenths. So either 38 or 38.0, that one's kind of weird. You won't have one like that on the test. How many sig figs? We'll say 2 or 3. This one is weird because we're guessing the ones. Okay, the next one. This one's a lot more clear cut. This is like what you would have on a test question. So 6.5, 6.6, 6.7. Okay, so this is exactly on 6.6. I can read that it's on 6.6. So I'm going to call it 6.60 milliliters. This one definitely has 3 sig figs. This is a good example of what you'll see on a test question to read. I won't give you one that's weird with like reading the 2 milliliters. Okay, next page. First, we've got to fill in our metric prefixes. So we have base, deci, which is 1/10, centi, which is 1/100th, and we have milli, which is 1/1000th. Then we have deca, which is 10. We have hecto or hecta, which is 100. And we have kilo, which is 1,000. Now, remember that kilo is K, hecto is H. Deca, to make it easy, we're going to make it capital D-A. Base can be meter, liter, or gram, and a bunch of other things too. Deci is lowercase d, centi is c, milli is m. Be careful with your m and m. Don't get those confused. Okay, so this next section asks us to make all these metric conversions. We're going to count by doing our hops and to also give the correct number of sig figs. Well, the number of sig figs we start with has to be the same as that we end up with in our converted number. So let's just count all the sig figs first to get it out of the way. Remember the 5 0 rules. So there's the, I wrote 50. 5 0 rules. Look back in your notes. Or remember that if decimal is present, count from the first non-zero on the Pacific side. If decimal is absent, count from the first non-zero on the Atlantic side. You'll get the same answer, and once you start counting, you have to keep counting. Pacific and Atlantic is labeled on the front wall above the board, so if you forget, it's up there on the wall. Okay, present decimal, count from the left. There are 3 sig figs. Okay, present decimal, count from the first non-zero. There's 2 sig figs. Absent decimal, count from the right. There are 2 sig figs. Absent decimal, count from the first non-zero on the right, there are 2 sig figs. Present decimal, count from the first sig fig on the left, there are 4 sig figs. And let's see, well, there's only one number there, 1 sig fig. Okay, so now we know how many sig figs are in those. Let's convert them. We should end up with the same number of sig figs when we're done, hopefully. Okay, meters to decimeters. So I'm going from the base to deci. I need to hop 1 decimal place to the right. So 1 decimal place to the right, that's 348. And yep, I still have 3 sig figs. That checks out. Hecto to milli. 1, 2, 3, 4, 5 to the right. So I've got to go 1, 2, 3, 4, 5 to the right. 980. Now, there are only 2 sig figs here. If I put a decimal, that would make it 3, so we can't put a decimal on there. Okay, so it has to be 980, and there's my 2 sig figs. And number 4, 34 centimeters cubed. We know that 1 cubic centimeter is exactly equal to 1 milliliter by definition, so that's 34, still 2 sig figs. Now I'm going from milli to liter, to the base. So 1, 2, 3 to the left. 1, 2, 3 to the left. 0.034. And yep, I still have those same 2 sig figs. Okay, centi to kilometers. So centi, 1, 2, 3, 4, 5. I just moved 5 places to the left. Here's my understood decimal. 1, 2, 3, 4, 5. 0.32 kilometers. And yep, still have 2 sig figs. That's good. Okay, grams, which is a base unit, to decagrams. So go from the base to deca, 1 to the left. 1 to the left. 23.4, you would think. But I gotta have 4 sig figs, so I'm gonna keep that 0. That gives me 1, 2, 3, 4 sig figs. And then we've got kilo to milligrams. I don't know if you're going to be able to see the yellow. Let me try this pink instead. Let's see if that's more visible. 1 sig fig going from kilograms to milligrams. 1, 2, 3, 4, 5, 6 places to the right. So decimal's understood to be right here. 1, 2, 3, 4, 5, 6 places to the right. Each one of those 6 loops needs a 0. So I've got a 1 followed by 6 zeros. So 1 kilogram is 1 million milligrams. And there still is just the 1 sig fig. Good. Okay, now for this next part, we're going to actually be using the sig figs in the calculations. So before we start, let's make sure that we have all of our calculator answers. I don't know why my smart screen's so upset. Let's make sure that we have all the calculator answers done. I wonder if yours also is missing this math symbol. We'll make up a math symbol for right there. Pause the video, make sure your calculator answers are done. Let's just make this one, I don't know. Maybe this is supposed to be 2. Let's make it 2. grams divided by 3.5 centimeters. I don't know. Okay, so here's our calculator answers. Now, our calculator gives us a very precise, very accurate answer, which might be more significant, more precise than the inputs. So look at the original problem for A. There's 1, 2, 3, 4 sig figs. 1, 2, 3, 4, 5 sig figs. That means my final answer can only have 4 sig figs. Okay, 1, 2, 3, 4. I need to make that zero significant. So what can I do? I can put a decimal at the end. So 2,390 period decimal centimeters squared. Do our check, count the present decimal, count the Pacific. 1, 2, 3, 4. Yep, that checks out. How about B? We've got a lot of sig figs right here. 1, 2, 3, 4, 5, 6. But here we only have 3. So I've got to take my calculator answer to 3 sig figs. So present, count from the Pacific. 1, 2, 3. Look to the right. Will the 1 round up that 0? Nope, it's going to stay the same. So 2.30 grams per milliliters. And here's our 1, 2, 3 sig figs, just like we wanted. Okay, for C, 1, 2, 3 sig figs, 1, 2, 3, 4. I'm going to 3 sig figs in my final answer then. Have to be I'm limited by my least number of sig figs. Can't be more precise than that. So 1, 2, 3, look to the right. What will the 6 do to that 0? It will bump it up. So 5.21 grams per centimeter cubed. This one, I'm sorry if it takes something different. Mine didn't print right. So 2, there's only 1 sig fig there. And then 3.50, there's 3 sig figs. So I'm only going to 1 sig fig, which is right here. Look to the right. 7 will bump that 5 up. 0.6 grams per centimeter. Okay, in our last section here is going to be on density. So show all work. This includes the formula, the substitution, and the answer with the correct number of sig figs in units. So let's start with our formula. Density is equal to mass over volume. Okay? And you can use the triangle or the algebra equation. Either way works. So this first question is saying, what is the mass, so mass is question mark, of a metal if it has density of 19.3 and the volume is 23.5? Okay, so let's start with our original equation. Density equals mass over volume. We can rearrange and solve first if you want. So mass is equal to density times volume, which is equal to 19.3 grams per milliliter times 23.5 milliliters. Before we start plugging into our calculator, just take a quick look. Milliliters on top, milliliters on the bottom, I'll be left with grams. So that means I did my algebra correctly. Okay, so take your calculator, and we have, what was it, 19.3 times 23.5, 453.55. So 453.55 grams. That's my calculator answer, but the problem asks me to get the right number of sig figs. So let's look back to our inputs. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. I've got to round this number to 3 sig figs. So 1, 2, 3. Look to the right. The 5 will bump the 4 up. So my final answer is 454 grams of this unknown metal, which if you look it up on the table, this actually is going to be gold. Okay, let's see your next one. What is the volume? So this time I'm searching for volume. Volume is question mark of ethanol. If its density is 0.9 grams per milliliter and the mass is 17.5 grams. So density is equal to mass over volume. Volume, if we rearrange and solve, is equal to mass divided by density. Let's plug in what we know. So 17.5 grams, and we're going to divide that by 0.9 grams per milliliter. Before we plug in the math, check your units. We've got gram over gram, and we end up with 1 over a milliliter, which if you go back to our notes in our practice, that is equal to a milliliter. That's an algebraic identity. Okay, so what's my volume? Let's get the calculator answer here. 17.5 divided by 0.9, 19.4 repeating. So we've got 19.4 repeating, and that's milliliters. That's my calculator answer, but my sig figs, okay, there's 3 sig figs in that number. There's only 1 sig fig here. So I can only give an answer that goes to the nearest tens place. So 19, rounded to the nearest tens, my final answer is going to be 20, no decimal, just 20 milliliters, because that density value was not very accurate or precise. Okay, last problem on the review. So what is the density? So density is question mark of a material, of an unknown material, if the mass is 23.9 grams and the volume is 43.0 milliliters. So density equals mass over volume. We're going to plug in our knowns, so we know that we've got 23.9 grams, divide by 43.0 milliliters. Take out our handy dandy calculator of science. 23.9 divided by 43, 0.55581. And why not? Let's throw a few more sig figs. 395. And that's grams per milliliter. Now that's my calculator answer. Look how precise that is. I didn't even go to all the numbers it gave me. That's too precise. It's too accurate. I need to round this to the correct number of sig figs. 1, 2, 3 sig figs. 1, 2, 3 sig figs. I've got to round this to 3 sig figs. Decimals present. I'm going to count from the first non-zero on the Pacific. 1, 2, 3. Here's my third sig fig. Look to the right and see how it's going to round. 8, we'll round that up. So my correctly rounded number is 0.556 grams per milliliter. Okay, that's it. We've finished our Chapter 2 review. Make sure you review your objective checks, your labs, and your practice packet, and you will do great on the test. Don't wait to be great. Until next time, guys. Bye.